All right. Hi, everybody. Good morning. I'm so excited to be here. This is the first in-person TREX, so thank you all for joining us. This is the third TREX workshop on trust and expertise in visualization, but we cover a lot of different topics of human-centered AI and like how visualization and human-centered AI can work together to improve the problems and challenges in this area. The topics that we covered are, for the past couple of years, it's been focusing on trust, domain expertise, different cognitive biases, transparency and explainability, human in the loop, and so many different things. A lot of people also submit papers that are very like more of these topics on visualization, not necessarily associated with any AI. So this year I had the chance to like work with a couple of brilliant people. Yeah, I just wanted to give a chance to each of them to introduce themselves. I'm not sure if Eric is here, but first of all, I'm Mahsan Noorani. I'm a PhD candidate at the University of Florida. My research area is obviously human-centered AI and XAI. Basically. All of the topics in this workshop, I work on them. And yeah, I would love to stay in touch. I'm also in job market. So yeah, next is Cindy. Cindy. Jesus.
That was a really, really great introduction for me. Hi, everyone. I'm Cindy. I'm assistant professor at UMass Amherst. Really great to be here and hosting this workshop with Masan and Ali and Britt and Eric. I do perception, cognition, visualization, and make sure to say hi when you see me around the conference.
Wait, why am I looking at myself? Oh, it's okay. Can we just move to the slides? All right. Next is Britt. Actually, we should keep the Zoom.
No one's hearing anything.
Oh, Britt is here. Britt, can you unmute yourself and introduce yourself? I think she's speaking, but we can't hear her.
First session, your first day, definitely symptoms of that.
We're doing everyone else a service by...
Nothing, huh?
I think she's speaking. I just can't hear her.
Well, you want to just introduce Britt?
I'm sorry. Okay, so Britt is a data scientist at Pacific Northwest National Lab, and her research interests are strategic marketing and machine learning, and I'm sure she was happy to be a part of this on her behalf. I'm also not sure if Eric is here, but Eric is an assistant professor at University of Florida. His interests are HCI, ACC, InfoVis, a lot of like interactive systems like 3D, VR, so on and so forth. He's also happy to be a part of this workshop. And last but not least, Ali Reza.
Hello. My name is Ali Reza Kardini. I'm just checking my name to see if I remember it correctly or not. I work at IDEO. I'm a computational social scientist, designer, something. And then I study HCI and decision making. I just need to remember that. But you're very happy to be here. Second time I'm co-organizing / sharing. So see you around at the conference.
Yay. All right. So just to cut it short, we have 2 sessions today. The first session is now, and we have 6 paper presentations. And at the end, we're going to have a hybrid breakout session where we're going to discuss some cool ideas together so you can get a chance to talk to each other and engage in discussions. And in the second session, we have a keynote speaker and 4 paper presentations. Our keynote speaker is here, Dr. Doug Marquand, and he is from University of North Carolina, Charlotte. And I'm super excited. This is his first time as Viz, and we're super excited to have him here. It's more like from a psychological aspect of visualization. So please make sure to tune in for that. And it's the next session. And you can go to our website up down there below the slide. We have all of the agenda up there, and we have all the papers, all the authors. So I guess I also have to say, if you have any questions for any papers, when any of the presentations and talks, I think there's a Slido that you can use to ask, post your questions, and the session chairs will ask them from the authors. All right. I guess that leads us to the actual first presentation. Oh, maybe I need to keep my laptop. Wait, we cannot hear. Oh, yeah. Yeah, thanks for understanding. It's a lot of logistics today.
Of physical disability in children, and repeat gait analysis is essential for selecting optimal treatment interventions, but it results in complex multivariate time series data. For CP, clinicians need to consider 58 biomechanical time series that exhibit intercorrelations and other complexities. Working with these data, clinicians need support in identifying pathological gait patterns, such as true equinus or crouch gait, in an effective and objective way. There are automated classification methods, but clinicians primarily need classification tools that they can trust. Thus, we developed Gait Explorer, an explainability-enriched visual analytics approach in a collaboration project with gait analysts. Our approach uses a convolutional neural network for classification and the GradCam algorithm to explain its internal functioning. GradCam is an established explainability method for visual data and determines the relevance of each input data item based on features learned in the last convolutional layer. Thus, we get relevance scores as time series of the same scale as the biomechanical input data. In the visual interface, we show GradCam's relevance score in 3 places next to the biomechanical data. First, there are detailed line plots of the biomechanical time series. They are based on the classical gait report. Here, the relevance score is shown as the color intensity of the corresponding line binned into 3 intensity levels. Second, to retrieve more detailed relevance scores for both legs, an interactive cursor provides details on demand. Third, a heat map provides overview of the relevance scores for all time series. We conducted a first case study with our collaboration partners, 2 clinical gait analysts at the Orthopedic Hospital Vienna Speising. For training the classification model, we used the anonymized 3D gait reports of 257 children, which were collected and labeled by our collaborators. To evaluate the explanations, we focused on a sample of 8 correctly classified patients from the validation fold. We conducted 3 group interview sessions as MS Teams video meetings, and in addition, between the first and the second session, we sent screenshots of the 8 patient reports to the clinicians and collected individual written assessment if they found the relevant scores plausible or not. Here is an example of a gait report that they both found plausible. Here is another gait report that raised concerns. Why? The clinicians stated they found these explanations suspicious because the relevance level was high for knee movement in frontal dimension and low for ankle movement in sagittal dimension. However, the true equinus gait pattern is primarily characterized by the ankle sagittal movement, both in the biomechanical literature and in their own practical experience. Overall, 6 of 16 leg explanations, 38%, were deemed plausible. About the other cases, the qualitative feedback revealed that the clinicians were concerned that the automated model relied on different regions of the data than they expected. Low relevance levels were more often criticized than high relevance levels. Then again, they emphasized that having visual interfaces providing such detailed insights are essential to gain trust in machine learning in the clinical setting. We hope that our Gate Explorer approach can serve as a reference for such explainability-enriched visual analytics.
For over 131 years, the University of Oklahoma has been making and making. It is a legacy of excellence.
Hello, now I can hear you.
I think
No.
no,
Okay.
no,
Okay.
no,
Okay.
no, no, no,
The first session at I have unmuted. All right. Well, my voice is not getting turned into a disco. I'm a little disappointed. But okay. Thank you, Alexandra, for the presentation. Now I get to ask my question after. Okay, so my question was that you mentioned that the clinicians tend to feel suspicious when they see data that is not super aligned with what they're expecting. I'm curious to know what they tend to do after feeling suspicious of what they're seeing. Do they just abandon the tool they're working with, or do they try to go into the data more deeply and explore what's going on?
In our case study, one of the practical outcomes for our medical collaborators was that we together should look in more detail about different ways that there are walking problems. Before they looked just at the different classes of cerebral palsy. For different classes of cerebral palsy, but didn't look at other problems that people have with walking. And one of the things that we will look into more details is, for example, how knee problems also affect how how classification works for the different cerebral palsy gait classes. So in machine learning terms, this will be translated into some multi-label classification systems in visualization data structures, maybe a set visualization problem.
All right, thank you. So for the sake of keeping us somewhat on track, on time, should we move on to the next presentation?
Hello. Oh, so can you move to the next one or?
Yeah, speak to the microphone.
No, we want to move to the next one. Yeah. All right, thank you, Alexander. Oh, just plug it in.
Plug this.
Oh, it's plugged in. Life is good.
So, do you know what your resolution is set to?
No. It
Just seems like we're getting a it's a sync. It's a sync issue, of course. Oh.
Well, we could have Ali do random, like ask him anything. Ask him anything, like. Ask him. Ali, you can do that, right? You can answer any questions. Oh, okay.
So I've asked, I need to entertain you guys. Still, this is fixed, and I'm like the funny person. So, what should I do? First of all, it's really great that we can fix things up before the actual conference starts. You know, even though this is going to be a great event, I'm not funny. I need to be a spur of the moment sort of funny, you know? I can't, if they put me on the spot, then I'll get all sweaty and like anxious. Now like I'm starting to sweat. Oh. Whew. Anyone has anything to say? Oh, the other professors? So, Eric? Yes. Masson is Eric's PhD student / candidate. So Eric is, do you want to talk about the other people while we are fixing things up? Just the other chairs that are not here, right? Yeah. 1, 2, 3, 1, 2, 3. You talk about Eric.
All right, Ali is usually really funny, but I'm extremely disappointed at. I'm just kidding.
Put me on the spot.
I'm just kidding. So while we put him on the spot, I came up with some pun jokes that I saw. So I thought I would entertain you with some punny jokes. So if you don't laugh, I would blame Ali for not entertaining you. So I actually have punny jokes. Am I supposed to should I actually tell them? Is that, no? Okay.
We can do something. So we will have a breakout session soon. We can start asking people to think about it. We want to make it.
Yeah, we can start thinking about our breakout sessions.
Yeah, why not? It's better to put me on the spot. I'm sometimes can be funny, but not always. So instead, the idea is that, and we will all have more time to think about it. So the idea is that we're in a world right now where we are trying to change minds a lot, right? With our systems, with our designs, COVID. I'm from Iran. There's mayhem right now happening, and a lot of people don't know how to bring people together, right? So the topic of our breakout discussions is how might we, or how can we change people's minds. Good. How about now? No. You need to mute that. Maybe we ask the questions from here, I guess. Okay. Yeah, so that's, anyone, is it clear what we're trying to do? So the idea is persuasion. The idea is because we're dealing in visualization and trust and expertise and humans in the loop, right? And then since this topic is sort of related on how people are persuaded, how people understand information online. In situations when things are tricky, when things are political, when we have to take a political stance and try to actually call for action or change people's minds, how might we? What are the solutions? What are the challenges? Have you thought about it? If you want to do it, what would you do? Your expertise. Basically, this is the sort of thing we want to discuss, because especially I sort of pushed it because I'm actively thinking about it because of my personal situation, because I feel useless. My people are protesting in Iran and I'm here just presenting to people, so it's not like I need to feel more, so instead of funny, I can make people cry. That's another thing that I have. Anyways, any thoughts so far? We can start? Yeah. Hell yeah.
She's actually here.
All right. You should have told me.
Yeah, no, we just figured it out. Oh, do you want to put that over?
Is that over there?
Hello?
Well, just put it here too.
Okay.
Okay. No, just go with it.
From University of Irvine?
University of California right now.
California and Irvine.
Yeah.
Cool. Please take it away.
Hi, so I'm Markel Kelly, and I'm going to talk about the paper I submitted, which is called Understanding Systematic Miscalibration in Machine Learning Classifiers. So the output of machine learning models is something that's already really widely used in practice in a variety of domains to help people make decisions that affect real people. So it's important that we can properly diagnose these models and understand their behavior. And in particular, I'm going to talk about tools for understanding the calibration of models. So to start with a motivating example, suppose we have a doctor who's tasked with diagnosing patients with different diseases, and suppose this doctor also receives as input the output of some machine learning classifier that's trained to predict the presence of cardiovascular disease. There are kind of two components of this output that the doctor would use: the actual binary prediction, yes or no, the patient has the disease, and then the confidence score. And the confidence score is a really important part of this prediction. It could completely affect the doctor's decision. If the confidence is low, say 55%, the doctor might choose to go with their own belief and not diagnose the patient. Whereas if the confidence is much higher at 90%, the doctor might be more willing to rethink their own belief and choose to diagnose that patient. So it's important that these confidence scores are a good measure of the accuracy of the model, that they're a good estimate of whether the model's actually likely to be correct. And you could imagine if of the observations where the model has 90% confidence, the accuracy is much lower, that could be a problem, and vice versa. So if the model is really overconfident, which is common with deep neural networks, or underconfident, we refer to that as miscalibration. And that's something that the doctor would want to know about their model and understand before they would use it in practice to make decisions. So traditionally, calibration is evaluated with reliability diagrams, and the idea here is pretty simple. On the x-axis, you either have the confidence or the predicted error, which is the inverse of the confidence, and then on the y-axis, the true accuracy or the true error. And basically, you want those things to match up closely. So of the observations with a 10% predicted error, you should expect that the model makes a mistake about 10% of the time. So this evaluation basically is just looking at whether the curve is close to that identity diagonal. And this is important. This is a good measure of calibration, but it's a very limited picture of the full story. And that's where our work comes in. So the idea is the doctor might have additional questions. How does the calibration of my model affect different people? Is it fair towards different people? And so we introduce these variable-wise calibration plots, and in this example, I'll talk about patient age. So it's looking at these same two quantities, the empirical and predicted error of the model, but with respect to the age of the patients. So you can see that these two quantities vary systematically with respect to age. So these two plots are from the same model that was trained to predict cardiovascular disease, but we get a lot bigger picture with this sort of plot. We can see that the model is really underconfident for younger people. It's giving a higher predicted error than what it needs to, and it's overconfident for older people. And these are problems that can really affect the decisions of the doctor in this case and really affect real people. So these are kind of problems that the doctor would want to understand to decide in which instances will I choose to trust the model or which instances will I kind of forego that prediction and use my own intuition. So just to kind of wrap up quickly, these plots are something that can reveal issues in fairness and just characterizations of models that are not apparent from traditional reliability diagrams. And in the paper, we go through some well-known models and data sets and show that empirically, these are biases that do exist that have kind of previously been undetected, and that these plots are useful for characterizing those things. We also go through some methods for recalibration of models, so recalibrating with respect to some variables such as age, and show that this is something that can help reduce these biases. So that's my summary of my paper. Check it out, and yeah, thank you.
Oh, there's sound. I'll yell, okay. When I was reading the paper, it's a very interesting work, and I agree that the problem of, that the calibration, variable-wise calibration can be a useful thing. One thing that kept coming to my mind is that in that realistic scenario that you just explained, how much time or willingness does a doctor might have in interpreting such a chart, and how might we simplify these outcomes to help them understand things? Do you have thoughts on that?
So there's some work that does look at, how much are, practitioners in industry likely to get out of visualizations of uncertainty and things like that. And these plots are probably in practice more useful for someone that's more on the model development side than the doctor themselves. And then maybe the summary of this plot or something is something that would be more useful to like just your average doctor who was used to just getting a single confidence score. And so looking at single numbers, like for example, or even not numbers, but just adjectives, saying the model is really underconfident for younger people and overconfident for older people, or with age ranges or things like that, might be sufficient for the doctor. Maybe the error bars and everything are a little bit much. But this is designed as a supplement to the reliability diagram, so anyone that's comfortable with the reliability diagram hopefully would be comfortable with this sort of thing. Yeah.
Other questions? Yeah, we're going to move to the next talk just for time. Thank you so much.
You could actually ask your questions on Slido. So
Hello, I'm Rarish Constantin.
Yeah, just ask your questions on Slido. Yeah.
Hello, I'm Raresh Constantin, a master student at TTH Zurich, and I'm very excited to present my paper with my colleagues, in which we propose a mixed initiative system for contextualized fairness assessment. Lately, fully automated prediction systems are used increasingly more for taking high-stakes decisions. However, it has been shown that laypeople sometimes do not trust automated decision-making systems in such situations. The main reason being that they raise some ethical concerns, since their decisions might be influenced by certain protected attributes such as race, sex, religion, and so on. Therefore, evaluating algorithmic fairness is vital. One simple way to assess algorithmic fairness is using manual evaluation. However, to adjust and improve a model, this evaluation needs to be done repeatedly, which is an extremely slow and expensive process. In contrast, automated evaluation of fairness is fast and easily scalable. Nevertheless, each predefined metric captures a different notion of fairness, and hence it is extremely challenging to determine which one is the most appropriate in a given context. The best fairness metric may depend on the details of the problem, the considered protected attribute, or even the people who assess the model's fairness. And for the latter, factors such as cultural background or technical expertise might influence the perception of fairness. To find a middle ground between the two methods, we propose a solution where firstly, laypeople manually assess a small set of initial models, and meanwhile, the same models are also evaluated using various predefined fairness metrics. And afterwards, we try to find the alignment between these metrics and laypeople's judgment, and then we can use the metrics with the highest correlation to automate the evaluation of algorithmic fairness for future models. Now, you may wonder how to find the alignment between the metrics and human judgment. For this matter, we proposed a mixed initiative system called FairAlign, which is easily extensible for any binary prediction task. The display diagram illustrates a simplified pipeline of our application, where firstly, the laypeople log in, choose an annotation dashboard, and start taking decisions regarding algorithmic fairness based on the provided visualizations of data and model predictions. After the annotation process is finalized, data scientists and machine learning experts can analyze the values of the predefined fairness metrics along with the aggregated results obtained from the human evaluation. The fairness annotation interface consists of dashboards containing multiple expressive and interactive visualizations of data and model predictions, which are split by protected attribute. Laypeople can select from the filtering panel on the left which other additional attributes they consider important for making a decision with regard to model's fairness. And in this way, they can get access to additional underlying information which can shift their initial perception of fairness. And after forming a decision, they must annotate the model with a fairness score using a Likert scale from -3 to 3, where 0 represents a completely fair model and each end indicating unfairness towards a particular demographic group. To validate the usefulness of our system, we conducted a small pilot study. And we have used the UCI adult dataset, which contains US Census data for almost 49,000 people, and where the task is to predict whether a given person earns more than $50,000 a year or not. And for the protected attributes, we selected race and sex. For this study, we chose 6 people, and for consistency, we made sure that all of them have low AI literacy and are part of the same demographic group. To be more precise, all 6 participants identified as white males. To quantify the alignment between the fairness metrics and participants' annotations, we use the Kendall-Tau-B rank correlation coefficient. And as seen in the table, results indicate that SP, which is statistical parity, has the strongest positive correlation for both protected attributes. However, The dissimilarity of results for other metrics between race and sex highlights the fact that human perception of fairness is highly dependent on the provided contextual information. And in addition, the relatively high variance might be caused by the small number of participants that partook in the study. In conclusion, our work confirms that there is no definition for algorithmic fairness that fits every situation. And furthermore, we show that FairAlign is a valid way to find how fairness metrics align with human judgment in a contextualized setting. The results we have obtained show that the judgment of people with little to no expertise in AI align best with the simplest notions of fairness. And we believe that this happens because they have more trust in simple explanations or visualizations than in more complex ones. Moreover, we have seen that the results do vary across protected attributes, meaning that contextual information is essential when evaluating fairness. And lastly, to obtain statistically significant results, an experiment with more participants needs to be conducted. In the end, I would like to thank all the co-authors for their contribution to this paper. If you have any questions, please do not hesitate to contact me or my colleague Moritz Duke using the contact information provided on this slide. Thank you for your attention.
All right, thank you for your talk. We have a couple questions in the Slido. So first of all, how does the selection of participants affect your analysis?
Yes, so because we didn't have much time for this study, it was just a study to verify that our work is indeed useful. We chose like close friends and people we know, but we made sure that all of them are lay people, so none of them had any kind of knowledge in AI. And as I said in the presentation, because our work is highly dependent on the context, we made sure that all of them come from the same demographic group. So yeah, this was the selection process.
Thank you. Then there is another question that says, like really important topic is from June. How do you think of the errors made by humans when they annotate the data?
Of course, it's a very good question. It's always important to consider the errors made. I think it's fair to say that for our pilot study, also because of the limited scope and the very limited amount of people, we just accepted any errors that might be in the data. But it's definitely part of future research and to evaluate our project, our framework against larger sample size. And in that case, it might make a lot of sense to really think about that more specifically. In the case of our study, the sample size is anyway so limited that we kind of just accepted any potential errors.
Yeah, and I think if we consider more people, one way would be to either exclude the outliers or just try to make the selection process better and just make sure that they understand the task they need to do. Make sure they don't just randomly select the annotations. So, yeah.
Much. There is one more question for you, but for the spirit of time, we're just gonna move on. You can answer them in Discord. Thank you so much.
Okay. Thank you.
Hi, my name is Yi Han. In this talk, I will share my thoughts on how future visualization systems could be designed to best support data-driven decisions. With the arrival of the big data era, many decisions are made with data. This type of decisions today largely depends on professional analysts to conduct analyses and generate visualizations for the decision makers. A typical data-driven decision-making process begins with a decision maker that needs to make a decision to solve a business problem using data. This need for data is then sent to analysts, where they may use a visualization system to analyze data and generate visualizations. The visualizations of the data are then reported back to the decision maker in a meeting, where consultants may be present to provide their opinions. Finally, a decision is made. In this process, the decision team that includes both the decision maker and the consultants may have trust issues in the presented visualizations, because of the lack of understanding in the data, the visualizations, and analysis process. These trust issues could all be caused by the analysts who act as the middlemen between the decision team and the data. So could we cut out the middleman here and let decision teams use visualization systems themselves in the future? Here, I present a future scenario of a data-driven decision-making process without analysts. A decision team needs to decide on whether to invest in a new technology for their company. Tom, a consultant, first asks the visualization system to show the market trend and financial breakdown of the new technology. The system understands his inquiry, finds the data, and shows the appropriate visualizations. As Tom presents, the system automatically highlights the relevant visuals. Ken, who is another consultant, does not understand the presented parallel coordinates visualization, so he uses a tablet to acquire a quick training on how to read it on the spot. Grace, the decision maker, questions Tom's market share estimation. So she asks the system to show their company's current market share of a similar technology next to Tom's charts to make her point. Julie, a consultant who participates remotely, jumps in and asks the system to show the two technologies' market fragmentations that may have caused the differences in their market shares. Grace is satisfied with this explanation. After more data-driven discussions, she approves the investment. This future scenario allows the decision team to directly access data without an analyst in the process that might alleviate some of the current trust issues. However, even to realize such a future scenario with relatively simple analyses and visualizations, 3 gaps need to be filled first. The visualization generation gap is about the challenge for non-technical decision teams to generate visualizations themselves. Today's visualization systems on the market can still be difficult to use for this user group, as using these systems require a certain level of expertise. The visualization interaction gap is about the challenge for non-technical decision teams to interact with visualizations themselves. Interactions can help customize visualizations and communicate findings. But existing visualization interaction techniques can be difficult to use as they may not be familiar to this user group. The visualization readability gap is about the challenge for non-technical decision teams to read multivariate visualizations. These types of visualizations are very effective in visualizing today's complex datasets. But some of these designs, such as parallel coordinates, can be difficult to read at first. Several important questions also need to be answered to realize the future scenario. For details on my ideas on how to fill the 3 gaps in my answers to these questions, please check out the paper. So what do you think future visualization systems should be designed to best support non-technical decision teams in making data-driven decisions? Thank you. Hi, my name is Yi Han. In this talk,
Hello, can you hear me?
yes,
All right, so thank you for the interesting scenario and like the story that you presented for us. One question that I have in general, and actually it's something that I'm dealing with at the moment, is in your scenario, I saw the person actually asked to be trained for what parallel coordinates are. In most scenarios, a lot of time there's time crunch and there's like a lack of willingness for even being trained. Do you see scenarios or opportunities or challenges in times where people are even not willing to receive training, given that there might be like a training for such visualizations in real time?
Yes, it's a very good point. It's a very challenging aspect as well. As with any technologies, I always believe that there are people who wants to kind of get ahead and take advantage of the newest things and learn the most. And there is always going to be some people who's going to be more reserved and need a little more guidance and even some more help. So I don't think it's going to be a fast process, but I do think that if we provide the right tools, the right methods, and nowadays with this strong emphasis with data-driven decision-making, I think there will be more people who's willing to take this leap and start proactively trying to learn what's going on with regards to their data and to make the best decisions.
We have a second question. So Paul asks, it seems there is another gap. How to compensate for missing tacit knowledge that expert analysis bring to complex decision-making scenarios?
So I think, yes, there's another aspect, absolutely, that there's always going to be things that experts may not be able to bring in some way, some tacit knowledge. So I do think that's a tough point, but we do try to see how much we can get out of them, because there's always this challenge of when the expert leaves, what happens to the knowledge that they possess, right? So there's this strong need to kind of see how much knowledge we can kind of get them to be instilled in the system, to have the system be smarter as more experts bring in their knowledge. And hopefully over time, we'll have smarter systems and a less need for experts to kind of know everything, I guess.
All right, thank you. We can move to the next.
Thank you.
Next, we have who will be presenting live. All right, take it away.
Sorry. Hello, my name is Eric Prince. I'm a third-year computational bioscience PhD student at the University of Colorado. And today I'm going to be talking about our position paper about using standardized process models as a means to bring artificial intelligence into the decision-making process in clinical decision-making within pediatric neuro-oncology. So the experience that a cancer patient has throughout the course of their care can be described along these different steps or stages. And so this is a brief example of a process model that they might experience, where at each stage, there's a different unique set of data that is interpreted by a unique individual, like a primary care provider or a radiologist, and they're doing a specific task within this specific stage. And we have identified many different AI applications that exist within these stages. Now, from a development perspective, we typically think about these in terms of siloed events. And so we think about an AI model for screening or an AI model for diagnosis, and we emphasize that. But what I will argue is that it's actually more of a systematic problem where we need to consider the cancer patient's whole experience in order to develop AI technology that'll bring us forward and actually improve this process that the patient actually goes through. So the kind of a brief example, if you look at the screening, we typically have a data type like MRI. So this is an image of a patient's brain, where we're going to be tasked with identifying a tumor, like here in the lower left area here. So the human that would do this is known as a radiologist. And the question that they're asking is going to be, do we expect a tumor? And as well as like that outcome being, are we going to surgically biopsy, or are we going to monitor this patient and see how they progress? Another type of imaging data from the diagnosis stage would be this like whole slide microscopy image. And so in this case, you still have an image of the tumor that was surgically extracted here, but a pathologist is going to interpret that, and they're going to ask what kind of tumor it is, and this is going to inform their therapy. And so from a development perspective, although these are both AI models and these are both images that AI models can be equivalently applied to, the actual instance that they're applied in is unique and not equivalent. And so what we need to do is develop a way that we can understand which models can be applied to each scenario. As a second, more concrete example, we look at the concept of the RAPNO process. So RAPNO is the Response Assessment of Pediatric Neuro-Oncology, and essentially it's a consortium of clinical experts that meet and convene and essentially describe a protocol for how to understand the progress that a patient is going through in terms of, are they responding to treatment? Do we need to intervene and do other things? And these are very rigorously defined tasks. And there are other consortia that exist in which we have different kind of parallel models that are not equivalent. But what we do know is that each of these models can be applied through AI, through process like what AutoRAPNO follows, where essentially we put AI models in each one of these boxes. And it's immediately then interpretable as to what that AI model is predicting, and the clinician can understand what's going on. But as I said, there's many of these models, and so that one-to-one comparison doesn't exist. And so we need to standardize the language and make a standardized process model ontology in order to integrate these in a more effective way. A previous example can be found if we look at the evolution from Web 1.0 to 2.0. So originally Web 1.0 was very static. It was form-based communication where a webmaster would put forth information and the user had limited interactivity with it. Eventually, vendors from technology groups, major technology groups, created this consortium called Object Management Group, where they created a standardized language so that technologies being created in different environments were starting to be able to talk together better. And what that ended up leading to is Web 2.0, where we have more dynamic interactive applications. And now we're moving towards Web 3.0 with the rise of blockchain technologies, and we're getting more personalized real-time implementations. What I would argue is that we're clinically in AI 1.0, where we have narrow examples where we can do static form-based communication, but we currently have a gap where we're not able to make it to this dynamic interactive applications. So our position is that gap can be filled through standardized process models, so a language that is predefined by the community in which we can create specified components and understanding of what each model is supposed to do. That's going to increase model interoperability and enable us to move different types of models reliably from one task to another and understand that it's predicting in the same kind of capacity. Also, by defining this framework, we have a systematic evaluation protocol, and we can do expectation setting, which is very important for trust, in which we can define with our community of stakeholders how each instance should be performing and what we should expect out of each one of these things. And it's measurable so we can always improve upon it. And it can be kind of an evolving system. And so ultimately, I think that this will open up the development community and allow different visualization researchers to contribute that don't necessarily have the biomedical knowledge that would be necessary to understand the nuances of clinical AI context. And with that, I would like to thank you for your time, and I will take any questions.
Thank you so much for a great presentation. We have a question on Slido. Can such process models be applied to other cases or situations where the decision-making task is up for interpretation, like an advisor assessing risk and success of students, for example?
Yeah, so essentially, the idea is really about defining the framework, and there are different ways that you can define that framework using either more declarative and defined examples like what I showed, or more imperative examples like what you're discussing, where we discuss more of a process. But the idea is that by defining the arrangement that these tasks have to come in, we can also define what the expectations are for different stakeholders at that task are. And that gives a more transparent understanding of what we're building these larger systems in order to make more interactive, like dynamic AI systems.
All right. Thank you so much. I guess if you have any more questions, you can ask on Discord. We'll move on with the next presentation. Thank you, Eric.
Thank you.
Hello, everyone. We are going to present our work on exploring the effectiveness of explanations for appropriate trust, lessons from cognitive psychology. And this is a joint work of me, Ruben Verhagen, together with Siddharth Mehrotra, Mark Neerings, Katelijn Jonker, and Mirte Thielman, as part of the Delft University of Technology. We want to illustrate the issue of explanation effectiveness with an example of one of the state-of-the-art explainers in the field, which nicely illustrates the issue For example, here you see output of explainability method, but the provided explanation is not that easily interpretable for humans. And therefore, we believe it's really important to study what should an effective explanation contain in terms of content, but also what should it look like in terms of modality, for example. And based on some insights from cognitive psychology, we argue the need to emphasize four main aspects in order to improve explanation effectiveness, which are perception, semantics, intent, and user and context. So what do we mean with this? In a nutshell, perception in effective explanations can refer to the set of mental processes that we use to make sense of a given explanation. And this often includes, for example, not only considering textual information, but also using visuals in order to make the explanation even more effective. In addition, when we talk about semantics in explainable AI, this basically refers to how an explanation designer wants to convey the message of the explanation, which ideally can improve the interpretation of it. And when we talk about the intent of the explanation, this basically refers to the purpose of it. And ideally, it balances the semantics with a certain goal that the explanation has. And finally, recent years in explainable AI, there's a rapid increase in interest in also considering the user and the context when both generating but also communicating explanations. For example, different users might require very different type of explanations.
Thank you, Ruben. I'll take on for the following slides. So we provided a use case example based on our four different components of the perception, intent, semantics, and user and context. We thought that if we design a task around the nutrition, which is as approachable domain for everyone, and we target how we can explain the perception of an explanation with matching the intent and the semantics that can be easily cleared. So we design an experiment such that with the help of an AI agent, the user needs to estimate the calories of a food plate. So if you see the burger, then how many calories you can estimate. So based on the AI agent suggestions, the user just need to pick 4 options, and there's a 1 correct option out of that. And afterwards, it's the explanation of the user which can be taken into account towards the final goal, which is like coming up with the final answer for the question itself. We have this slide which demonstrates the use case example. You can see towards the slide, we have a table described in a format as labeled A, which shows the confidence levels of the different ingredients identified by the AI agent. This clearly shows how the semantic and the perception of the confidence level of different ingredients can be understandable by the human user. And on the level B, we have the visual explanations, which towards matches the overall criteria of the dish, which is on the right-hand side of the figure. So it explains that these are the best matches or the good match or the unsure matches towards the figure, which is already there for the estimation of the calories. Finally, the system provides an explanation based on the user and the context itself, taking into account the perception and the semantic meaning of the overall figure itself. Based on all these different criteria of 4 different components, we summarize that we need to have different explanations designed in such a manner that dedicate towards the 4 components as we have described in the overall figure. Finally, we showcased through a use case example that how communicating the different components based on the perception, intent, semantics, and user and context can be an effective method for designing effective explanations. Thank you.
Hello, everyone.
thank you for the presentation. So while we're waiting for questions to pop up on Slido, I do have a question myself. I'm wondering if you foresee any potential harm bringing a standardized model into this process.
Sure. So I think once we have this particular process of semantics, intent, and the perception part very clear, it also demonstrates the issue when, as an AI system designer, you have certain biases embedded in yourself, and those process gets deal on to the later stages where the actual use of the AI product is by the user itself. So what you perceive as the AI intends to do and the meaning which needs to get out of that, it's totally different when a user gets matched with that, right? So this clearly highlights there's a perception gap of what the AI designer perceived to design the system itself and how it is actually being used by the user. So it highlights the process where you can actually see the harm which can occur into the system.
Awesome. Thank you, Siddharth. Okay, I think we have a question from our live audience. I'm going to pass them the mic.
Hello, thank you for the talk. I wonder, because you only show the total calorie estimation in the interface, I wonder, because you detect the ingredient, right? So I wonder, can you show the breakdowns? It will seems more persuasive to me. For example, the meat, the calorie is about maybe 400 calories, or yeah. So can you do that, or do you see the values or difficulties in doing that? Yeah.
Sure. So the example which is on the slide is just of a burger, and it was a pilot sort of a user study, but actually we thought that after doing this pilot that it's better to use the dishes which are mostly clear in the depiction, so that like a salad. So in the salad, it's easily identifiable that whether it's a carrot or whether it's a brinjal or something like that. So the AI system can make a guess that if you have 5 different pieces of carrots, then how much calories it can be. And combining all the different ingredients, it can give a kind of like an approximate value of the total calories of the food plate. So that was mostly on the technical level.
All right, thank you. I think we have some remaining questions on Slido, but for the sake of time, I'll post them on Discord and we'll move on to the next components. Thank you again for the presentation.
All right, because I don't know if everyone heard me properly in the beginning, I'm just gonna give a very quick overview of what's gonna happen after this. So we have on our second session 4 presentations, and our keynote speaker, I lost my cursor somehow, by Dr. Market, and please be back after the break. Before the break, we have a breakout discussion with all of you, and also if you're a hybrid attendant who wants to join the conversation, we have a Zoom link. For the ease of entering the room, we use the Yell key. So use the first one to enter, and then there's a Miro board that all of you can use to share your ideas with all of us. So the idea is to do discussions, maybe talk about your discussions on Miro, and then at the end of the workshop, we will try to kind of create a collective of what the results of these discussions were. And I think Alireza can introduce you to the discussion for 2 minutes before we break out.
I did it once, right? But that was sort of as an awkward filler, so I'll just repeat my thoughts again exactly. As I mentioned, we're all, with COVID and a lot of the different situations that we've faced where our decisions have societal outcomes or just personal individual outcomes, there is this notion of how can we call for action? How can we persuade others to take actions, the people who might not be interested or who might have differing opinions, beliefs, attitudes? Misinformation is a case, protest is another, war is another. or any other thing that you might be interested in, or you might care about, women's rights. As a personal challenge that I've been facing is that I find it really hard to persuade others to change their minds. Now, given data and information, a lot of times we can make data-driven decisions, or a lot of time models are there to help us with misinformation, with a lot of things. The hope for this sort of breakout room discussion brainstorming session is for us to find out some of the domains that you might have engaged with or wanted to engage with, is anything in your professional or personal life. Some challenges you might have faced or you think you might face, and then come up with strategies and ideas on how to deal with them. So it's a very open-ended, I hope you all get involved, but we have a bingo board. So if anyone really, right now we have a sort of an starting with an awkward silence. If no one really said anything, we'll, scratch that. But there's a lot of stuff, right? So I hope to get, at the end of the day, get some domains and challenging ideas and maybe possible collaborations for us to get into. This is my hope. Maybe I can find collaborators to deal with the thing that I'm dealing with, or ideas, but in general, maybe we can help each other. Any questions? We have a thing here. So there's a Zoom, but we can talk in person as well. There's the Miro board, but we can also, if you can sign into the Miro board with the Yell key, you can also type your ideas in there. But if you rather be typed with your voice, and then we can type for you, basically. We'll be your AI assisted thing. So